It's easy to worry about the effects urban traffic have on air quality and the health consequences that come along with it. In collaboration with the Norwegian Institute for Air Research, we students at Elvebakken High School have researched particle pollution and CO2 levels to discuss the following issue. Is it better to sleep with the window open or closed in Oslo?
Our hypothesis was as follows. In Oslo, it is better to sleep with the bedroom window open than closed.
To examine the air quality, we built an air measuring device, which consisted of an Arduino Uno and the Nova SDS-011 particle sensor, which measures the frequency of PM 2.5 and PM 10 particles in the air. We chose to also add the CCS 811 CO2 sensor so that we could examine several factors of the air quality at the same time. To activate the sensors, we had to upload a code to the Arduino from a computer. Codes that use the sensors can easily be found online and modified to fit the needs of any project. Our project was located inside our bedrooms, which meant that there was no need for either a protective box, an SD card, or a battery, because the collected data could be stored directly in our computers, and the computer powers the sensors as long as it's connected to the Arduino. If an air measuring device is located outside, one can easily connect a battery and a micro SD card adapter, like this one, to the measuring device, which can store all the data that the sensors collect. The only thing is you must add to the code that the collected data be stored on an SD card. Our air measuring devices were placed in 3 homes in Oslo with different levels of car traffic. Location A was close to the city center and near a moderately trafficked street. Location B was outside of the city center, but next to an active street. And location C was outside of the city center and away from any regularly trafficked streets. Our measurements were made from the 16th to the 18th of March 2020.
We adjusted our code so that the air was measured every 5 minutes, and we turned on our air measuring devices in the time course 10 p.m. till 8 a.m. for 2 nights. One night with the bedroom window open and the other night with the bedroom window closed. The collected data was presented graphically and compared with the National Institute of Public Health's criteria for air quality. These were the results.
The closed window measurements show low particle values throughout the night, except at location C. Location C started with high PM values, but these decreased during the night and stabilized at almost the same level as locations A and B. From this, it is concluded that the normal level of PM10 and PM2.5 at location C with a closed window is the same as of location A and B, but that a source polluted throughout the day, possibly the construction of a school being built near location C. CO2 levels were much higher with the windows closed compared to open windows, and these passed the National Institute of Public Health's recommended levels for indoor climate. According to the National Institute for Air Research, the amount of airborne dust rose above normal in Oslo during the period this project was carried out. This was due to dry weather that whirled up airborne dust and may have affected the results. Despite the increasing amount of PM10 particles that come with the window open, the amount is still below the recommended levels. Unlike this, the CO2 levels were above the recommended level when the windows were closed.
Therefore, we conclude that our hypothesis matched with the results. The research shows that it is better to sleep with the window open in Oslo.
In this project, we have become more knowledgeable about the local air quality. This project has allowed us to apply the knowledge we have gathered from past projects, such as programming and the scientific method, to perform our research. Most importantly, we have learned how people without a professional background can conduct their own research from home. Thank you for watching!